All right, guys, we're live for the second time in this class period. Okay. So, changing gears, but not really all that far. Okay. I'm going to give you an example equation first, and then I'm going to give you the generic whatever. Okay. So, that's the parent function. Okay. Let's say it gives you a function. It's not the parent function. This is the parent function. This will be something different. Like x squared minus 6x plus 10. Should look somewhat familiar to our topic on factoring, which, by the way, factoring, if you didn't master the first time, it might come back to haunt you when we get to some topic within quadratics. We will need to use factoring. Yeah, I know. Yeah, you guys. So it's just that's why I told you factoring. That's why I spent so much time on it. This is going to come back again. We're going to have to do it all over again. Okay. Is this a quadratic? Yes or no?
Yeah.
Does it have an x squared in it?
Yes.
It does, right here. Okay, so it's definitely a quadratic. Awesome. So it definitely has a U shape. Now, what if they tell us, oh, find the axis of symmetry, or find the vertex, or what does it even look like? And yeah, you could make a table of values, fine, but there is actually things we can do besides making a table of values. Okay, we can find key points that will help us graph it.
What if we like making a table of values?
Then you totally can, except for the fact of if I'm trying to find the vertex here, and my table of values gives me 5 points. Like let's say the quadratic looks like this, but the 5 points I get are here, 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 and here. Well, then how do you know where the vertex is? Yeah, fine, you got the U shape, but I tell you to find the vertex, and you're like, crap. What x value do I need to pick? So that's a great suggestion, but might not work if we're trying to be very precise with our parabolas. So let's go back to the topic of axis of symmetry. Okay, we've discussed this. Axis of symmetry. Okay. We can actually find this without even looking at what the graph looks like, believe it or not. Before, you saw something like this, and I told somebody, I think it was Vasilisa, I told her to come up on the board and show me where the axis of symmetry is, and she was like, oh, it's right here. And then Lucille came up and said, oh, the vertex was right here. That's great if we can see it, but if we can't, it's a problem. But there's a way to do it. Ready for this? So there's a formula to find it. So before I discuss the formula for axis of symmetry, let me erase this for a second. I need to discuss with you one topic before we get there. We will discuss this next. The general format for, now this is called a quadratic in standard form. So I'm going to write that down. Quadratic, there's different forms. Just like, for linear equations, there's slope-intercept form, point-slope form, yada yada. There's different forms of quadratics. The first one we're going to discuss for the meantime, for a little while, okay, is your standard form. So quadratic in standard form. Okay, and this is actually in standard form. But if I had to give a general formula for standard form, I'll do the formula here. Okay, so this is a quadratic. Here's an example of a quadratic in standard form. And here's the formula. And the formula is f of x equals ax squared plus bx plus c. Does this look familiar to anyone? No?
Yeah.
Yeah? Okay. I'll actually use some different colors here since I have the option. I'll make my A value pink. No dot there. And I'll make my B value, let's make it blue. B for blue, I guess. And my C value will make it orange. Okay, because we're gonna need. Why do I color code these? Because the formula for axis of symmetry, we're gonna use these values. Okay. All right. So I'm gonna give you a formula now for axis of symmetry specifically. Well, actually, before we get there, sorry. Based on this equation above, we're going to stick to this example. What is my A equal to? What is my B equal to? And what is my C value equal to? Can you guys help me identify those three values? Here's your formula. Here's the example I gave you. So based off this example, what is my A, B, and C? Yeah. A equals 1, says Lucille. A does equal 1, for example. There's no number out in front, so we're going to say it's a 1 there. Okay, so yeah, that was, there's nothing here, but there's a 1 there. What is my B value? Yeah, oh. -6 is my b value, -6. So let's just make this in blue so we can just keep the colors there, -6. What is my c value?
10.
Emily? 10. It is 10. What color am I using for c? Orange? So it's a positive 10, or just 10. Positive 10. Okay? That should be c. c equals 10. Okay, good. This is so important because we're going to use values of a, b, and c for our vertex. All of these values will be used in the formulas we're going to be addressing. So let's go to that topic of axis of symmetry. The axis of symmetry. So formula here. Formula for axis of symmetry is what I'm writing. Axis of symmetry. How do you find? Now remember before when we had axis of symmetry, I think it was Luke that told us this one was like x equals 4 from before. So it's going to be x equals something. So axis of symmetry formula is the following. X equals -b over 2a. That is the formula for axis of symmetry. If you do this, you will find exactly where the axis of symmetry is. I want you guys to practice it on your own because this is just a very simple formula. You plug in the b, you plug in the a, you find the value. I'm going to pause for a second. Find me the axis of symmetry formula. Sorry, find me the axis of symmetry, not formula. Just the axis of symmetry for that example.
Wait, I want to do it.
Yeah, I have this written out. I'm not going to. Okay, so I plugged in, if you guys are confused, I plugged it in with colors over here, color coded it. So you know, here's the formula, -b over 2a. We know how to find a, b, and c now in our standard form. So you're just plugging it in. So negative, and I put
double negative, it's positive 6, right?
Yeah. Double negative is positive. But every time I plugged it in with a parenthesis around it to stay organized. Please keep using parentheses.
X
as an
equals
organizer.
3.
So Logan says x equals 3. Do we concur? Yeah. So x equals 3, which means if I'm drawing this out, I'm going to move this example for a second. If I'm drawing this out, I know that my axis of symmetry will be at x equals 1, 2, 3. I know to find, and we'll graph this in a second on a graphing calculator. We're going to see if we're right about all this. I hope we are. We know that that's a value of 3, so here's my axis of symmetry, x equals 3. And we know my parabola is either going this way around it or this way, but it's either here or here, something. Here's the next topic for you. Okay, so axis of symmetry, -b over 2a. We're going to practice that, okay, in a bit. Did you know you could just look at this and know if it opens upward or downward? If it's a regular u, like we first saw for the parent function, right? If it's a regular u that goes like this, or if it opens the other direction, it's simple. I'll write over here. If a is greater than 1, it's going to open upward. This is called opening upward. Okay, that's the term they use. Opens upward is the actual mathematical way to say it. Opens upward. If a is less than 1, aka negative, or sorry, did I say greater than 1? Greater than 0. I'm so sorry about that. Yeah, I erased that in notes. It's 0. Essentially, if it's positive or negative. Okay. If it's greater than 0, it's positive, it opens upward. If it's less than 0, it's negative, it opens downward. Opens downward. Okay. So based off our example here, does it open upward or downward? What do you guys think? Opens upward. Yeah. So we know the U is going to look something like this. Okay. So since that's all we're covering, I can actually kind of draw it in. So it's going to be something like this. Oh, but we don't even know where it is. It could be up here. It could be down here. So I'm not going to draw it yet. But it could be like this. It could be like that. It could be like that. We know it opens upward somewhere. We just don't know where. Which brings us to our next point.
We plug in.
Yeah, how'd you know that?
Always plug in.
Yeah, so we're going to plug in order to find, we want to find our vertex essentially. Okay, so here there's a vertex that's lower, here a vertex slightly higher, here the vertex is the highest. So we know where the axis of symmetry is, but where does that actual vertex fall? Where's that tippy point here, since it opens upward, you're going to have a minimum dot, right? So let me actually write this. Means you will have a minimum. Means you will have a minimum.
A equals 1.
Here, you will have a maximum. So here you're going to have a minimum if it opens upward. Here you're going to have a maximum. So how do you find it? Well, guess what? The axis of symmetry and the vertex always are on top of each other. So if the axis of symmetry here, the vertex has to be on top of the axis of symmetry. How do you find where it is? Take your axis of symmetry, value 3, plug it back into the equation, and find what the whole point is. So your vertex is going to be in this format. So your vertex format is going to be x comma y, okay? But we already know the x value. It's the same as the axis of symmetry. So we know it's going to be 3 comma something.
1.
And Logan, you plugged the 3 back in and it gave us 1?
Yeah.
Let's take a look. 3 squared minus 6 times 3 plus 10. Class, what's 3 squared?
9.
9. 9 minus 18.
9. Negative 9.
Negative 9. Negative 9 plus 10? 1. So we know this is going to be equal to 1, which means my vertex is at 3 comma 1, which means 3 comma 1. It's actually, here's my vertex, which means that it should look something like this. Okay? Okay. I'm going to pause for now. I'm pretty sure that's it. Okay? So I'm going to open up a worksheet for us. I'm going to make an assignment for it, and it's going to involve these topics. Okay?